In this video, we're going to talk about inequalities involving quadratic functions. Just as a little reminder, these are inequality symbols, so greater, greater than or equal to, less than or equal to, or not equal to are all inequality symbols. And we represent inequalities in a number of ways. So using those symbols, any combination of all those symbols and numbers and variables, as well as number lines, as well as interval notation, which we have covered recently. And oftentimes you are asked to find when an equation, specifically a quadratic equation, so x squared, blah, 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 is greater than, equal to, or less than, or some combination of those, than 0 or some other number. So, as a visual reminder, anything that's above the x-axis is when f of x, or y, is greater than 0. If it is on the x-axis, that's equal to 0, and if it's below the x-axis, it is less than 0. So remember, f of x represents your y value, hence why above the x-axis, f of x is positive, and below the x-axis, f of x, or y, is negative. So let's just jump in with an example, shall we? So let's say I have this inequality. This quadratic function is less than or equal to 0, and then we'll graph the solution. So the first thing that I'm going to do, and I hope is your intuition as well, is to factor this quadratic function. So I first factor this to x minus 6, x plus 2, because that multiplies to negative 12, adds to negative 4. I set them both equal to 0, and I find that my two x-intercepts are at 6 and negative 2. So the next thought that I have is that, okay, I have my two x-intercepts. I have x equals 6 and x equals negative 2, these guys. And I have a positive x squared, so I know that that parabola is going to open up. So I have a relatively decent idea of what this parabola is going to look like. And I want to know when it's less than or equal to 0. So that is including the x-axis and below. So where does that function exist? So, spoiler alert, if you find your two x-intercepts for your quadratic inequality, the inequality either exists between them or on the outside of them. So if it is a positive curve like this, like a parabola that opens up, and it is below the x-axis or less than or equal to, it's going to be between. If it happened to be a positive parabola like this one, and it was greater than or equal to, it would be on the outside, and vice versa if it is a negative parabola. So that means that my function is going to exist, or the x values that will make this true are going to exist between negative 2 and 6 inclusive. So we would write it just like we would domain, so either in interval notation or set builder notation. So here's the better looking graph than mine. But we can also see that where does this function exist below the x-axis, including the x-axis and below. So it starts at negative 2, it exists all the way from negative 2 until we get to 6. And we'll also include 6, forgot to mention that. And for our next example, we have the same directions, but a different quadratic. So we've got 2x squared is greater than x plus 10. There are two big ways that we can do this. One is to graph the equation 2x squared, so that's a parabola, and graph separately the line x plus 10 and see where they intersect. So they could intersect at probably 2 points, because a parabola and a line intersect at 2 points. And we can figure out what y values are greater on this parabola than it is at that line. So it's either going to be outside of the two intersection points or between, or we can move over the x plus 10 to the 2x squared side and solve it the way that we just did the last problem, which is what I'm going to do. So let's do it. So once I move over the x and the 10, I get 2x squared minus x minus 10 is greater than 0. I just set that equal to 0. So I'm going to use factoring by grouping in order to factor this, but there are so many other ways to factor a quadratic with a leading coefficient that is not one. So very quickly what I'm doing here is I do 2 times negative 10, which is negative 20, And now I need to figure out what two numbers multiply to negative 20 but add to negative 1. So that's going to be negative 5 and positive 4. And that's how I rewrite my negative x. Negative 5x plus 4x, which add to negative x. So I split that down the middle. I factor this guy, and then I factor that guy separately. So I end up with 2x minus 5 times x plus 2. Set those both equal to 0, and I have my two x-intercepts. So next I imagine what the graph will look like. So I've got a positive a value here, so that's positive 2, so I know that parabola will open up. So given negative 2 and 5/2 as my x-intercepts and that this thing is going to open up, I'm looking for the values where y is greater than 0. So that's going to exist on the outside of the function. It definitely won't exist between because that is below the x-axis. Between is where it's negative. So on the outside is where the function will actually exist greater than 0 for the y-axis. So in interval notation, it looks like that. And in set builder notation, it looks like that. And again, here's a much better looking graph than what I sketched, but our function will exist outside of our two x-intercepts. Yet another example. It's like this is a math video or something. So same instructions, different quadratic. Gonna try to factor this. Let's see what happens. So I go to factor this thing, set up my x and my x. The only two numbers that multiply to 1 are 1 and 1. But there's no combination of positive, negative. That will give me a positive 1 here. So I think, all right, I gotta plug that into the discriminant, which is the thing under the radical in the quadratic formula. So that's b squared minus 4ac. b is 1, a is 1, c is 1. Plug it in, I get 1 minus 4, which is negative 3. What do I know about the square root of a negative number? It's not real, I'll tell you that much. So I have no real roots. With a function that has no real roots, that means that the quadratic, in this case, either exists completely above the x-axis or completely below. So in graphing this function, I can see that it exists completely above the x-axis. So where is it greater than 0? Everywhere. So that would be all real numbers, either an interval or set builder notation. And conversely, if I kept the same equation and said less than 0, looking at the graph here, are there any points on that quadratic function that exist below the x-axis? Nope, not even a little bit. So we just say that that has no solution. All right, that's going to do it for this video. Thanks so much for watching.